All right, welcome everybody to the first Friday, the end of the first week. Hopefully, it's been manageable. I will say, based on my experience, each week it does get easier. The first week is definitely the biggest adjustment, understandably so. So today, if we look at the schedule, we are scheduled to talk about mainly chapter 5, but if there are any other issues with previous chapters, previous concepts, then we can, of course, discuss those again as well. But I want to start with a focus on chapter 5.
Super sad. Oh,
Say again?
oh, sorry. I didn't realize I had my audio on.
It is sad that it's Friday. I know.
I'm sorry.
You subconsciously knew it was on. So let's see here. Where are we in the book? So, I mean, it's guided by you, whatever questions you may have. Now, as we progress away from part one, things are going to get much more straightforward. More straightforward in terms of what is required, what kind of questions you should be preparing for and thinking about. It all becomes much more sort of streamlined, I guess, when it comes to Roman numerals. The Roman number system, we are aiming for, I'll say, two basic kinds of questions. The first one being, can I convert to and from a given a Roman number? Given a Roman number, can I convert that to a decimal number? And given a decimal number, can I write the corresponding Roman number? So that the two conversions, that's the first one. And then the other one is the arithmetic. Where is that? Oh, here it is, later on. So there will be one page in the quiz dedicated to Roman number conversion, both ways. And then there'll also be another page dedicated to arithmetic. Now, I don't know. I'm not going to necessarily ask all three of these, addition, subtraction, and multiplication, but I have to be ready for either one of them. But it's quite straightforward in that those are the only kinds of questions you need to prepare for. I think there was a typo. If you look at the answer key to the problems, there is a typo in problem 5.3. I'm not sure which one. I think it's number 2. So just be aware of that if you happen to look. Hopefully the others are all correct. If you find that this is not enough, um, especially with the arithmetic, notice that you can easily make up your own arithmetic questions. You pick some decimal numbers, you convert them, and then you stay in the Roman number system and do the arithmetic, and then check what the decimal answer is, and you can do that. But when it's in the test, I want to make this very clear. When you do arithmetic in the test, it's going to say you have to stay within that number system, in this case, the Roman one. If you write decimals when you do a question like problem 5.6 number 1, if you write decimal numbers, convert it, then do the arithmetic and convert it back, that is a 0. That is not the question. The question is to do the arithmetic within the Roman number system. So you have to stay in that system. And that emphasizes the basic uh, arithmetic method, addition, subtraction, multiplication, that we will mainly be doing in the lower grades of elementary school up to five-ish. So by being in a different number system, that's not completely foreign. There are strong connections to our decimal system, but it's different enough to force me to really pay attention. What is the method to add multi-digit numbers? How do I carry over? What does that mean? What are the steps? I really have to be more aware of that. And in that process, I can better teach that. Because for the decimal number system, we don't even look at the what the numbers mean anymore. We just go through the motions and our thinking shuts off. So by doing this in a different number system, we are forced to pay a little bit more attention and really know what steps we're doing, when and why, and so on. Well, I'm not seeing any questions, which I guess is a good thing. So, yes, I
Actually,
hear a noise.
Stephen, can you please answer one of the, like, before we leave today, could you also just go, I think we kind of went over it a few days ago, but how many questions again, and what sections to really focus on for next Friday?
Sure, there
I
aren't
know this
any
is
questions other than that right now, so we might as well. Let me just go to the index here, table of contents, I mean. So we will have 5 pages in the quiz. Five.
per
Not
per
long because you have just an hour, right? It's
yeah,
not long. The first page is mainly mainly 2.1. However, there could be one of the parts on that page could be referring to the three types of reasoning: inductive reasoning, deductive reasoning, and abductive reasoning. Do you have an example for each of those? And do you have a pro and a con for each of those? So it's sort of chapter one. Um, yeah, let me make this more interactive here. I'm trying to draw on the PDF in an efficient way. Let me give it a shot. Why not? All right, let's do this. Ooh, let's go with blue. Blue's pretty good. So if I look at quiz one, I'm really looking, page one rather, I'm really looking at this, page one. But understanding that very few things are coming out of chapter one. It was very much, excuse me, introduction chapter. So we want to have inductive, deduct. I'm not trying to put a line through it. Can I erase? Whoa, what happened there? There we go. That's better. Inductive reasoning, deductive reasoning, abductive reasoning doesn't really have its own section. Do I have an example of each? And pros and cons. The writing on an edge isn't great, so I apologize. It's not me, it's always the software. And then, of course, the problems and exercises here when it comes to negation, logically sound argument, those are all good to go. So that's page one. Then we'll have a page on Karuji or Sudoku because they are awesome. Again, Sudoku won't be 9 by 9 because there's no benefit to doing that. It's just time consuming. You don't actually have any deeper insight. Karuji could be 3 by 3 or 4 by 4. Sudoku, what should I call it? I guess a 6 by 6, we'll call it. Yeah. Everything good so far?
yeah, that really helps. Thank you.
All right. Now I have to scroll. Lady and the Tiger gets page 3. Page 3. Let me scroll down here. Whoa! Too much scrolling. Scrolling is a little sensitive. Lady and the Tiger. I want to draw. There we go. Page 3. And there's not much to clarify when it comes to that. It's just a matter of seeing the variety, pick your strategy, try and get some confidence, know what you're going to do going in to a Lady and the Tiger problem. Have a plan going in, I would say, is the most important, whatever that plan may be. Then other logical puzzles. That would be page 4. Could be knights and knaves, could be something with house colors maybe. But regardless of what it is, even if it sounds on the surface very different, it's always going to be a strategy that you've seen before, or a strategy that is very close to what you've seen before. If you have worked through all the exercises and problems in 2.4, the strategy is not going to be anything fundamentally different. Oh man, the scrolling is not good. There we go. And then, of course, page 5 will be a couple of chapter 3 questions. There are some that are quite elementary, like making a table, making a list. Those are easier and simpler questions. The more difficult and I'd say important questions are the water containers. Ooh, ugly writing there. Working backwards. What else do we have? Uh, some, I'll just say it like this, some calculations, like 2 plus 4 plus 6 plus 8 up to a point. Do I know the strategy for how to do that? Uh, and then maybe there's some overlap between these strategies. I can't really isolate any one of them. But those are the main ones that give the most difficulty, have some complexity to them, but do be aware of the others as well. And yeah, that's the quiz. Quiz 1. Easy. Can be easy, especially if you have the book in front of you, but it's there's not a lot of time to study a topic during the test. You're going to have to go in fairly prepared and know where to look, and you can do a refresher, but there's not a lot of time for unpreparedness. Then chapter 4 here is just for interest's sake. You'll see that there are no questions or problems or anything. Just sort of where do these number systems come from? Why did we even bother with numbers? How did we start to gain efficiency in how we work with numbers, le- leading us to our main two number systems. Roman numbers, very relevant. You see the Roman numerals around if you look. Super Bowl numbers, things like that. We are connected to the Roman numbers, definitely. And then the seemingly different Babylonian numbers, which will happen on Monday. Okay, I'll minimize that. Any questions that came to mind during my rumbling? Otherwise, I'm just going to do some random arithmetic questions if no one else has a question.
I found that I struggled with the last two problems at 5.6 and 5.7, which I guess are the
Right,
arithmetic.
arithmetic, exactly. And there aren't that many to practice, so let's just make our own. Now, we don't want to go crazy and make them too big. It doesn't really, it's not necessary. So let's just make some. Let's make an addition one. Let's make an example here. I'm totally just making these up. I have no book or anything that I'm working from, and I don't want to take these few problems that you have, so we'll just make our own. Let's go in the thousands. We can make it maybe a couple of thousand here. Let's make something like that. And I'm already spacing it because we have to keep the powers of tens, the thousands, the hundreds, and so on in line. That's our method. It's a part of it. Set it up. Let's go maybe just an L, and let's go with 4 maybe. We'll add. What can we add? Maybe a couple of thousand there. And let's make a couple of hundred. Let's go maybe a little bit bigger 10. And let's go with another 5. That's a decent question. There's nothing wrong with that. Now, admittedly, when it comes to arithmetic in decimal numbers, I have some views on that, but I don't want to introduce a whole mix of strategies for arithmetic. I'm going to stick to the one that most people know. That's the first one they go to, especially when they have when they're doing written arithmetic, which is working right to left. When it comes to mental arithmetic, that's a different game. We are doing written arithmetic, and right to left has a very nice stepwise procedure to get us to the answer. Now, as was said in the video, the Roman numbers, they're very much still a decimal system. I'm working in tens, which is why I line them up in the same way as I would my own numbers. So here I have, now I'm not speaking their language, I'm still speaking English. So I'm still looking at that and saying 4 plus 5 is 9. I can't write 4 plus 5 here. If you do that, then I'm going to subtract 1 for every decimal number I see. And this is only going to be a few marks, so it's essentially going to be 0 very quickly. That is my way to force you to stay in this number system. So I can think in any language I want, any system I want, but what I write down has to be a Roman number. So 4 plus 5 is 9. I write the representation for 9. Nothing is carried over. Well, maybe next time. I have an L here, which is, just to see if anyone is paying attention or I'm talking to myself. Either way, I'm good.
50.
50, yay. 50 plus 90, this is a special pair. 50 plus 90 is 140. Okay, so I'm going to carry 100 over, and 40 is left. 40 is a special pair as well. Not that you have to put a box around it. Well, that's a special pair as well if you want. When it comes to the conversion, identifying the special pairs is super important. Not right now. Well, no, to be fair, it is important because I have to line things up correctly. Anyway, moving on to the hundreds column, I have 100 plus what?
400.
400. Yeah, it's nice to take part. Makes me feel better. I'm not talking to myself. 100 plus 400 is, of course, 500, and then another 200 gives me 700, and that is a straightforward listing of the letters. Nothing is carried over. Then to the thousands column. There's a lot of screaming kids in the background. I apologize. I have 2,000 plus 7,000. That gives me 9,000. 9,000 is one of the last special pairs, which is going to be 1,000 less than 10,000. And I'm done. So my special pairs extend into the thousands, and that is it. 4 and 9, 40, 90, 400, 900, and 4,000, 9,000. And there we go.
Do you mind explaining like the last part? I'm sort of confused about like the M and then the X with the line over it.
Now I'll write this out for our purposes, but just keep in mind that should not be done in the test. Okay. So I have 2,000 plus 7,000, and we all know that's 9,000. but I have to convert 9,000 to its Roman number, and I will go to that place in the book. Where are the extended table of thousands? 9,000 sits over here. That's a special pair, just like 900 and 90 and 9 is one of those special subtractive pairs. 9,000 is 1,000 less than 10,000. Just like these, where were the original subtractive pairs here? 9 was 1 less than 10. Let me zoom in. 90 was 10 less than 100. 900 was 10 less than 1,000. And 9,000 follows the same pattern. 1,000 less than 10,000. So I just have to convert that 1,000 less than 10,000. So it's not these subtractive pairs, the couple of thousands ones, did come a little bit later in the introduction for obvious reasons, but they follow the same pattern. Everything's exactly the same, as if we said this over here. This was exactly the same. I had a 4, I had a 5, my answer was 9. I write the 9, which is a special pair. It's no different, really. It's just a different subtractive pair. It's one of the 9s. Just like this one over here was one of the 4s. It was 40. And then I had to remember the representation of 40 is used with 2 letters. So definitely I do not want to go on to arithmetic if my conversion up to 100,000, let's say, you can stay below the million. If my conversions aren't super solid, then going to arithmetic is maybe not the best idea. I can't really rush these things. I have to build these things up in the correct way. There is a process. Some things should come before others. So if you feel like, oh, I'm running out of time, I should get to arithmetic. No, you're doing more damage if you're not ready to go to arithmetic. If your conversions aren't very solid, then this isn't going to be as easy as it should be. Any other questions on this specific one? Is it quiet
Hello?
because it's easier?
It makes
Can you
sense.
hear me?
Yes, I can.
Could you go over 5.5, like changing it into a decimal number?
Sure. This is pretty much these kinds of questions. There aren't many. No, that's an exercise. These are the only ones we're doing, right? We're converting back and forth. We are doing 3 arithmetic questions. That's it. That's all chapter 5 is. And that's all that chapter 6 is going to be as well. The number system is just going to be different. Which one did you say? I don't want to do this one, but I guess we could. Which one of 5.5?
Yeah, mine's different though in the textbook.
Well, this is the one that is on the website, is it not?
It's under 5.1, but it's exercise 5.5.
Exercise 5.5. 5.5. Ooh, all
Oh
right.
yeah.
That one?
Yeah, can you do A?
Sorry, I
or
thought
B or
problem.
C?
Sorry, yeah. Number, which conversion direction?
Can you start with
Or both?
well, can you do one of each?
I'll just do both. Randomly A, B, or actually, let me, let's see if I can write it on this. What page is this? 58. Whoa, what did I do there? No, don't do that. What have I just done? 58. Oh, go back. There we go. Zoom.
Stephen, in the lecture, you said these exercises wouldn't be or aren't really testable. Is that the same for us, or could something like this be on the test?
I don't see much benefit in testing the double line size numbers. Like if you go into the millions, now you have 2 lines, right? Because it's 1,000 times 1,000. So it's interesting to know where this would have to go and what they did, but it wasn't really designed for numbers that big. They didn't really think they were going to have quantities that large.
Right.
So if we stay under 1 million in terms of converting, in terms of arithmetic, I think that's a, a fair test question. That if you can do that, then you can very easily go higher, but it's not, there's no deeper insight suddenly. So the level of numbers, the size of numbers in exercise 5.5 is kind of as high as I want to go. This 6 million is unnecessary, but we can totally do it.
Okay.
Just sort of as an indication. This is like exercise 5.51. These guys are perfectly good test questions. Yeah. So which one should we do? A, B, or C? They're all the same, really. Maybe C is the hardest one. I'm totally guessing, but it doesn't really matter to me. We want to identify. I'm gonna zoom in some more. So let's do C. We're doing C. The simplest way, perhaps, is to think of tens and hundreds and so on until I have a whole line under stuff. So here is my ones number, and maybe I can work backwards. Let's go right to left. That is an ugly 9. See if I can make my pen smaller. It's okay. I'll just write big. So, hey, right. 9. There we go. That's nice and big. Then my tens number is where? The D is a hundreds number, so it's just that X. So it's going to be 19. If this feels a little backwards, we can do another one forward. Is it okay to do it this way? It doesn't really matter which side you go. I still just have to, I have places, I have digits here. Some of the digits just have multiple letters. That's the only problem. And my D is the hundreds number, and that would be 500. Then I have a thousands number, which is this guy. That's a special pair.
4,000.
That is 1,000 less than 5,000, so that's 4,000. Sorry, I'm just coughing a little bit. All right, now I can do all of what's under the line, or I can keep looking for the next digit, the next place, which is 10,000. That would be these guys here, 10,000, another 10,000. That stops over there, right? And that's 20,000. Then this guy is 50. Under the line is 50,000. So that will be... Oh, no. I did that wrong. I'll back it up.
I was going to say, wouldn't it be 1,370, and then but then you add the extra zeros?
Let's pretend I did that on purpose.
Okay.
Just to see if you were paying attention. That would be 50 and another 2 tens. That's 70. With a line over it is 70,000. So I have to erase this 20,000. So 70,000. And then my next one would be over here. That's the hundreds with 10 under the line, 100,000s, and that's 300,000. This flickering mouse is bugging me. And then I have 1,000 with a line over it, which would be the 1 million. Now, whether I did that from right to left, I just maybe did that because the smaller parts of the number, those are more familiar. Whereas if I start with the big ones, maybe I wouldn't separate it nicely. Like here I have 10,000s. Then I have a special pair No, I do not have a special pair. What am I saying? I might run the risk of not looking deep enough into the number to see the 1000s, the hundreds, the special pair for the tens, and then the ones. So this first one, if I wanted to do it, since we've sort of done it, I have 30,000. Then I have an 8,000. Then I have 500. Then I have a special pair, 40 and 6. So whether I do it right to left, left to right, whatever works for you, right? There's no difference. I still have to separate the places just like our decimal system does. Just some of those places have a different amount of letters. Then in well, first of all, any questions on that direction of conversion? I can't remember who asked the question. Does that feel better? That one at least.
Sorry, that was good. Thank you.
Okay. Just checking. Don't want to move ahead and then we have to come back to this. It'll be confusing. So let's maybe do B. B is a nice testable question. So again, I treat each digit separately, understanding the place that it's in. So I have 800,000. So 800 would be
DCCC.
it's 500 and a couple or a few hundreds, 800, and you can break up the line. Think of the connected line as a font. It's nice. It looks nice when it's all one connected line, but I don't have to write it like that. I can focus on one digit at a time and have a gap here to keep track of where I am and have the line broken up. Doesn't matter. Not for our purposes anyway. Then 60,000. So then I'm looking for 60, make it 1,000 or times 1,000. Then I'm looking for 4,000. So that I have to know is a special pair, 1,000 less than 5,000. Then I'm looking for 700, DCC for 500 and another couple hundred. Then I'm looking for 30, and it becomes more and more familiar, and I finish it. And then you can go back and connect that line if it really bothers you. It doesn't bother me. Think of it as a font. My writing style is to have the broken line. Doesn't make it any less wrong or right or any more right or wrong. Doesn't change it. So maybe that helps you, keeping the digits completely separate in your mind and then just stringing it together. If you leave spaces between them, I don't care about any of that at all. How about that direction? How does that feel? Understanding that we are doing math and your feelings are quite irrelevant. There's no feelings in math. It's all logic.
Test will be expected to do it both ways, obviously.
There will be both, yes.
Okay, thank you.
Just not all the arithmetic won't be there
Right.
because it's too much. It makes the test too long. But you don't know which one you're going to get, so we have to prepare for all of them. So that's the conversions. We can certainly do more. I just don't want to take from your problems. There aren't that many. I guess I got lazy here. You could very easily make your own, put some in the course chat. No one's using the course chat. Oh, it's very sad. Someone did, but not a lot.
Can we go over like the other arithmetic way, like
Yes.
multiplying?
I just want to check that everyone is ready to do that. But we'll leave multiplication. Actually, let's do multiplication now. Because multiplication is perhaps closer to addition than subtraction is. I don't know. Maybe. And as I said in the video, I hope I should have said, that there are two versions of multiplication, right? Just in case you haven't watched the video, just read the book. Let me just clarify that. There are two versions of multiplication, or the basic multiplication method, the right to left method. there's still two versions in how I write it. If I go to decimal numbers, if I say, for example, 927 times 4, the way we might be doing it, just if we just have to quickly scribble something and calculate the answer exactly, is to do it as fast as possible. 4 times 7 is 28. 4 times 2 is 8, plus 2 is 10. 4 times 9 is 36, plus 1 is 37. Totally fine. But we have one foot in the teaching side as well. So I would personally, I would never teach this, to be honest. If a student later on, after multiplication is sort of settled, come up with this short version on their own, totally fine. I won't fight them on it, but I'm not going to push it in any way because the time is just a risk of if they go to this too fast, they lose track of what to do with all these digits. And the more I write down, the easier it is to keep track of. So the longer written version of this exact same method is definitely, in my opinion, the preferred way to go. So then I say 4 times 7 is 28, and the 20 goes in the tens column. Then I'm going to multiply 4 by 2. It's not really 2, it's 2 tens. So I'm going to get a number of tens. So I'm going to start over here, and I might as well put the 0 there to keep things in line. I do say 4 times 2, but it's really 4 times 2 tens will be 8 tens. Then I'm going to go 4 times 9 hundreds. So my answer is going to start here in the hundreds, and I pad it so that everything is nice and in line. 4 times 9 is then 36. It's really 4 times 9 groups of 100 is 36 groups of 100, but it's very tedious to say, so we drop the groups of 100 every time. And then I add these up, right to left. Addition is still carrying over the 1, there's nothing wrong with that. And of course I get the same answer. But this method, it's the same method. This more detailed presentation of the method just makes it much, much easier to keep track of what I'm doing when I'm teaching it or someone's learning it and still a little shaky. If you're super proficient, yeah, do whatever you want to do. So I want to, when I now go to the Roman numbers, I'm a little unsure perhaps. I definitely want to go to this one. More detail is definitely better, and less things I need to keep track of in my head, the easier my life's going to be. That said, if you do the left version in Roman numbers, I'll still accept it because I understand what you're doing. It might just not be, just don't force it. I think if you force this left short presentation version, I've seen some mistakes happen. All right, that was my rant. Let's make up a Roman number. We don't go too big, like maybe in the thousands, maybe. Let's go MV with a line, just to see it. Let's go with a DC. Let's go with maybe an XL. Let's go with a V. Now I don't want to say X here, but my time symbol is going to look like my X, so I'll write times. Do not think, oh, there's another X there. No. And we're not going to make this number super big. We'll stay below 10. We can do it 10 maybe, but nothing crazy. I'll stay below 10. Pick a number. I don't know. What should we multiply by? It's your course. It's your session. You should have some input here.
5.
5 sounds good. 5 is nice and easy. Oh, that was not a straight line at all. 5 it is. All right. So I still say this in my comfortable language, of course. 5 times 5, 25. So that would be 2 tens and a 5. Now, there's no 0 in the Roman numbers, so there's just going to be empty space somewhere, so I do need to keep everything nicely in line. I don't have the luxury of padding with a 0. 5 times, what is this? Ugh, this is 40. 5 times 40. Now, if you go and write here, 5 times 40 equals 200, I'm going to subtract a lot of marks for that. I have to stay within the in the Roman number system. Can't show any other numbers because I want to avoid converting, doing the arithmetic, converting back as much as I can. It's trying to test if you can stay within this Roman number system, and therefore, do you really understand this multiplication method? So anyway, 5 times 40, we said is 200. That's going to leave two hundreds, C's, in the hundreds column and nothing else. So I just have to line things up. A lot of empty space with multiplication often. Now I've done this one, I've done this one. So I'm now multiplying with the hundreds portion of this number, which is DC, which is 600. 5 times 600. Well, 5 times 6 is 30. Groups of 100 is 3,000. Now stop me if you're not super happy. There's a lot of things we're doing in our head, for sure. But nonetheless, it's the method that I'm trying to think of in this less familiar looking number system. So I've done the hundreds. Because it's 5, it's leaving a lot of gaps. 5 times 4,000. Well, 5 times 4 is 20. So 5 times 4,000 is 20,000. So I will have 20 here, make it 1,000. And then I'm going to add all those. Straight line, sort of. Not much to do with the addition. Very rarely do I actually have a complicated addition with any sort of carryover or anything. So it's usually as simple as just, especially when I multiply by 5, just bringing everything down, putting it in one line. It's the method. It's the method. And this just makes me a little bit more aware of what is the method? What do I do next? Why do I do that? And so on and so on. Whereas in this top version, the detailed version, I don't even really think about what I'm doing. I'm so used to it. It's been so many years of looking at these digits. I become naturally efficient in optimizing my brain power, I'll say. So the thinking involved, it sort of becomes mechanical and I stop thinking. But if I'm going to sit in front of little Timmy, for whom this is very foreign, perhaps, I need to really know the method so I can guide him through. Like, why do I put the 8 over here? Because it's not 4 times 2, even though we casually say that, it's 4 times 2 tens, which is 8 tens, which is 80. And little things like that. So with this Roman system, arithmetic, I'm just raising my awareness and really carefully going through the method. How do we feel about multiplication? Perhaps a little closer to addition. Yeah, there's no borrowing or anything here.
Feels good.
Feels
I have a question
good.
for the test.
Yes, absolutely.
Say if we did it like the right way, but we just made like a little mistake, so the final answer was like a little off. Would
No,
we get
exactly.
it all wrong?
Oh, no. If you, it's the method, right? It's trying to see, do you understand the multiplication method? If, for example, I just had a lapse in concentration and I just wrote 1C here. I was looking out the window and not paying attention. And it happens. Absolutely. I mean, it doesn't happen to me because I'm perfect, but I guess it happens. Then you've still shown that you know what you're doing, and I would subtract the minimum I can subtract, which is 1. But
Makes sense.
hopefully, I mean, yeah, there's a luxury in it being an open book test for sure, that my requirement is what it is. It says, don't put any decimal numbers in your answer on the page. That doesn't mean you can't go scribble it somewhere else.
Yeah.
And double check by way of converting. So you do have that check, and then if you do, you've done it the way it should have been done in the question. You go on the side in some scrap paper and you scribble down the decimal versions and you check, is that the same as my Roman version? Oh no, that means I did something wrong, and I can go double check. So we do have that luxury to have that safety check, but no. I mark with a mistake as much as I can.
Thank you.
It's not an all or nothing, absolutely. Alrighty. Next up is the wonderful subtraction. Just 1 second, I will be right back. Okay, back. Sorry about that. Let's make some subtraction questions. Oh, I'm in eraser mode. There we go. Now with subtraction, we'll start with a basic one and then we can spice it up. Let's go with maybe a 2000, and then let's go 900. Let's go with a 50, and let's go with maybe an 8. That should be big enough. And I'm subtracting. Let's suppose I'm subtracting 700. I'm trying to make this a mid-range question. We can make this one bigger. Let's say 90, and let's say 9. Mid-range. Some borrowing. Sort of. Maybe a little higher than mid-range. Anyway, there it is. So let's do that subtraction. Again, right to left. That's the written subtraction method that everyone knows and loves. So we say 8 minus 9 can't be done. I'm going to have to go borrow from the tens column, and I always borrow just 1. So I'm going to borrow 110. That then changes the 50 to a 40. And I'll worry about that 40 later. I'm in the ones column. I now have here a 10 and an 8, so I have 18 minus 9 happens to be another 9. Then I'm done with the ones column, move over to the tens column. Tens column says 40 minus 90. Nope, that's not going to work. Top one's too small. So I borrow from the hundreds column. I always borrow just 100. That then changes what I have in the hundreds column. I have left 800, and that is represented with the CCC. Now in the tens column, I have enough. I have 140, from which I can take 90 to have 50. Then I'm in the hundreds column. I have 800. I take away 700. I'm left with 100. Nothing was borrowed. I still have 2,000. Nothing's taken away. Done. What I would just want to make a note of is some people, not many, some, try and see patterns in letters and try and eliminate and merge letters in a clever way without thinking about the number behind these letters. That is going to get you in trouble. Sometimes it seems as if there is a shortcut, and it's just not going to work all the time. It depends on what these numbers are. So think about the number represented by that column, in that column, and then do the subtraction in your head in English in the decimal system, and then just convert the answer back.
I have a question.
Sure.
So like when you do like multiplication or subtraction, can you change the original question to decimal numbers first, then like do it, then like translate to?
You were breaking up a little bit. I think you said, can you convert it to decimal numbers first, do it, and then convert it back?
Yes.
That is the opposite of what you want to do. That is exactly what we don't want to do. That is the test is asking, because everyone can do that. There's no challenge in that. We are trying to see, do you really understand the method by taking me outside of my comfort zone into this different number system? The method is the same, but it looks way different. So I have to, in the test questions, stay within this number system and demonstrate how it's done in that system. And it'll say, if you write numbers in any other system, marks will be deducted, something like that. To try and force you, you have to stay within the number system.
Okay, thank you.
But, like I said, you being on your own writing the test, nothing prevents you from double checking it on an extra scrap piece of paper you don't submit, just to verify that your answer is what you would have gotten if you did do the conversion. But in terms of presentation of the question on the paper you submit, there can't be any decimals on there, any decimal numbers. That will pretty much be a 0. And that theme is going to carry forward into chapter 6, new number system. We're only doing 2 number systems, can't be that bad. Where the same thing will happen. I'm trying to step out of my comfort zone, because only then do I check if I really understand the methods that I will be teaching. And you don't want to be the teacher that gets a question, oh, why do we put this digit over here? Why do we do that? And then suddenly you realize you've never thought of this. You've just sort of mechanically did it because you are so used to it. And then on the spot, you have actually no idea what to say. That we don't want to do that. So this is all aimed at the method behind the many, many letters we see. Let's do another one. Let's make it as hard as we possibly can. And then nothing else you see is going to be that tough. So let's take, let me make it as difficult as I can. Let's take 9,000. That's it, 9,000. Minus, actually I'm going to put it in line here first. So the question is going to have it all in line. 9,000 minus, let's say 1,000. Let's say 700. Let's say 99. There's my question. Oh, they're playing with a cat. Poor cat. Anyway, there it is. So my first task, the first thing in that method that I very easily forget about, is I have to line these things up, tens and hundreds and all that. Now the first number, because we don't have any zeros, we don't see the place as easily as our decimal number system. So we'll do our setup first. This is going to be a thousands number. So I have some blank spaces for the hundreds, the tens, and the ones. There's no symbol to keep that, which is one of the downsides to this number system. That the length of the number I see, the length of the representation doesn't directly correspond to the size of the number. I have a smaller number on the right, yet its representation is way longer, where that doesn't happen in our decimal number system. A substantially bigger number will have a longer representation, so you can visually assess the size of numbers much more effectively. But they didn't have that. Their numbers weren't that big, perhaps. Now I line the thousands up, so it's a 1,000. Line the hundreds up with pretty much nothing. Line the tens up with nothing. Line the ones up. Use nice spaces here. Give yourself the space to keep track of what you're doing. Just as a check, is everyone with me with this question? This is pretty much as hard as it is going to get for subtraction, right? And if we can handle this, then we can handle anything. Any thoughts so far, or are we good to continue? I'm trying to stretch this out. We don't have that much to do today. No thoughts? I know you're speechless. Yeah. Speechless.
I did it. I'm just curious.
Sorry?
I did it, and I'm curious if I did it right.
Yes, we are going very slowly for a reason, because I want to make sure everyone is keeping up, and it's hard for me to guess. So, now let's maybe think. Separate piece of paper. Let's remember a similar situation in the decimal version. Let's say 3,000. I'm just gonna make it bigger. Sorry. 3,000 minus 1,729. What would I do? I still go right to left. I still go to the ones and say 0 minus 9 can't be done. I need to borrow from the tens. There's nothing to borrow. So in order for me to borrow from the tens, I need to borrow from the hundreds, and there's nothing to borrow. So I need to borrow from the thousands. What do I borrow? I always borrow 1. I borrow 1,000. Now we have a more efficient way of writing that. That's 10 hundreds, and we don't have to write all the zeros there because I'm in line. That updates here to a 2,000. Now I have enough to borrow. What do I borrow? I borrow 100, which is 10 tens. And then this becomes 900. Then I'm ready to borrow from the tens column to the ones column. What do I borrow? I borrow 110, which is 10. And this then becomes 9 tens that I have here. And I don't write all the zeros because the decimal system is designed to be more efficient in how we write things. So then 10 minus 1 is 1. 9 minus 2 is 7. 9 minus 7 is 2. 2 minus 1 is 1. And I'm done. So if I have empty places in a row, I'm going to have to do this sequence of borrowing. The method doesn't change. Nothing about this method is different. I just have to keep track of what I'm doing when it looks a little strange. So I'm going to have nothing, and I'm going to subtract 9. Can't be done. Need to borrow from the tens column. This is still the tens column. What do I borrow? I have nothing to borrow. So I have to borrow from the hundreds column. Can't do it. There's nothing. So I have to borrow from the thousands column, and I'm only moving to the next column. So from the thousands column, what do I borrow? That was a question. What do I borrow? From the thousands to the hundreds.
Do you borrow?
I always borrow
1,000?
1. I always borrow 1. And its name is M in this case, because I'm not allowed to write 1,000 in the decimals here, right? And then this is updated. It was 9,000. It is now 8,000. 8,000 looks like that. Okay? I'm going slow on purpose because I know this isn't easy for everyone. And if it is easy for you, great. But that's not what these sessions are necessarily for, right? So I'm trying to go as slowly as possible. Interrupt me at any point. Don't wait until the end and then say, why is this V with a line and 3 M's? Well, now I have to go back all the way. Stop me when it happens. I'm trying to go slowly to give you opportunity to interrupt me. Do not feel that you're being rude. Now, my goal is still to get to the ones column because it's right to left. So that's the first thing I do. I just don't have anything. So then I have to borrow. Sorry, I should have made an arrow here. Then I have to borrow from the hundreds column to the tens column. How much do I borrow? It's not silence. No, it's a letter. What do I borrow? What letter do I borrow?
Is it a C or
It's a
100?
C, yes, because it's 100.
Yeah.
Then I had 1,000 here. That is no more. I now have 900 left. The representation for 900 is CM. Still trying to get to the ones column, so I need to borrow again. From the tens column, it doesn't matter if this is a C, it doesn't matter what it is. I'm in the tens, well, I'm borrowing from the tens column. I therefore borrow 110. And the 100 that was there gets updated to 90, which has its subtractive pair representation. Now, finally, I'm in my ones column and I have enough to subtract. I have 10, I subtract 9, 1 is left. Done. Moving on to the tens column, I have 90. I'm subtracting 90. I have nothing. Blank space. There is no zero symbol. Moving on to the hundreds column, I have 900. I'm taking away 700. I have 200 left. Done. Moving on to the thousands column, I have 8,000. Taking away 1,000. I have left 7,000. And I am done. The method in no way changes. That is going to become even more important to realize in the next chapter when things look even a little less familiar. The method does not change. The whole point of this, there are many other number systems. There's the Egyptian number system, the Mayan system, all kinds of systems. But they're so far detached from our decimal system that they don't, in my opinion, have an obvious benefit to study from an elementary school mathematical point of view. The Roman number system is still decimal. It's just a little step away from looking familiar. And it allows me to really think about the method. What is this borrowing? That when I sit in front of little Timmy and he's doing subtraction with a lot of digits for the first time and really have to do the digits, what's that, maybe grade 2, I know exactly what goes where and why and can guide him how he needs. That is the point here. That is the point. Am I ever going to teach Roman numbers in elementary school? No, sadly, I think they've removed it completely almost. What's left is extremely superficial. But that's not the point here. The point is the method of written arithmetic that I will definitely be teaching all the time. And it's not easy. It's not easy. I have a grade 3 and it's not easy. It's very strange to them, very foreign when they see it for the first time, where I've seen it for years and I don't even appreciate what the method is doing and the challenges that come with it. Now we have a little bit of an appreciation for what those kids might be experiencing. Thoughts, questions, comments, criticisms, compliments? No compliments, I know.
Yeah, I guess I've been looking at the textbook wondering why we need to do this, like even the Babylonian stuff. But
yeah.
Yeah.
One thing at a time, right? When you get to chapter 6 and sort of have gone through that chapter, look back, we're going to do the
Mhm.
same thing on Monday. I'm going to
Mhm.
say the same thing. The method didn't change.
Right.
And because what's the point of learning strange methods you won't be teaching, right? This method you will be teaching, well, unless you're teaching kindergarten, sure. Chances are extremely high you're going to be teaching this. Their
Mhm.
worksheets are full of it. So it might look weird on the surface, but it's very much aimed at what you will probably be doing. As soon as you scratch the surface of the Roman numbers, then yeah. Now, admittedly, this isn't really how they did arithmetic at that time. They just used little stones and moved them around, of course. But that defeats the purpose of what we're trying to do. So historically, I'm not being super accurate, but uh, it's a math class. It's not a history class, so who cares? So try and see. I think the most benefit you can get is to try and see things for what they are, not for what they appear to be. They appear to be super scary, perhaps, and very strange and different, but they're really not. It's all superficial. They have a lot of benefit for me, which is why I'm only looking at these two. They have a lot of relevance and help me better understand the decimal system when I don't even think about it anymore. If you were to do arithmetic for yourself, you don't even think about what you're doing. You just go through the motions. But as a teacher, that's the very, very bad thing.
I currently teach grade 4 and teaching multiplication. This is
Well, yeah, yeah.
exactly it's totally applicable.
Yeah, and I mean that jump to, let's call it multi-digit multiplication, that's a big one.
Yeah, just so they actually know what they're doing rather than just
Yeah,
following whatever you tell them. It's
exactly.
important.
And I mean, it comes to who are we sort of training? Are we training robots that can just go through the steps without really knowing what they're doing? I think that defeats the purpose. You have to have that number sense of, and the method. I think if we understand the method, and borrowing and carrying over and all those kinds of things. That's where the number sense is laying. What do these numbers actually mean to me in quantities and groups of quantities? Just going through the steps, I can write a computer program to do this, and there's no understanding. That's sort of missing the point, but it's very easy to do, especially when you have a teacher that they don't really understand what they're doing. They can go through the steps, but because they don't really understand, they can't really explain why the steps are what they are, and they can only ask the students to copy and duplicate the steps. They can do that, of course. Kids are very adaptable, but there's no understanding. There's no number sense. And if you look at the breakdown on the curriculum, BC curriculum website, number sense, it's an important thing that we're trying to develop. Or something equally profound, I don't know. Something like that. Trying to stretch the session. We have like 22 minutes left. Don't know what else we can do. This is
Are
chapter
you
5.
sorry? Are you able to just like you know how you went over what's going to happen on quiz 1? Can
Yeah.
you, if there's no other questions, could you maybe just go over what to expect for quiz 2, even though we haven't gone over all of it?
Yeah, absolutely. Let's maybe do this version. Well, while we're here, this is very much page. Oh, I hate a P like that. Get away from me, P. Get a slight personal issues with a P that is not nice. Anyway, page 1. It's right there. Now all you have to do is mix it up enough to make sure you can do the conversions. Convert one way, convert the other way. We'll stay under 1,000,000. So let's get rid of that 6,000,000 there. There's no benefit in a test, I feel, to go above 1,000,000. And then I've actually, where am I now? I'm so scared to scroll in this in Edge. I don't even have a scroll bar. That's nice. How do I even scroll? Ah, got it. Page? Ah, genius. All right, here we go. I'm actually going to call that page 3. You'll see it's page 3, the arithmetic. For no reason at all. It's just going to happen to be page 3. Not all of it, not all addition, subtraction, multiplication. I try and not ask the same one twice, but we are not going to have enough questions to cover each of them. But in order to be prepared for whichever one you're going to get, you have to, of course, do all 3. And that's all we've really done so far. Now, chapter 6, the Babylonian system, will have very similar, a similar style, conversion, arithmetic. It's pretty much it. Just a different number system with its own rules and pros and cons. I'm not going to ask pros and cons, but it's good to be aware. What's good about the Roman system? What's good about the Roman number system? For us, at least. Would you say? Is there any pro to this? Or it's all con, me making your life miserable? Yes.
Quite familiar to us. Like
It
you
is.
said
It's
with the Super
definitely,
Bowl.
yeah, definitely more, probably the most familiar of these older number systems. And I think another pro is that it is very much decimal under the surface. We're still counting in tens and hundreds and thousands and so on. Con, like I said, you can have, like if I look here at the top, 2000. It's a very short representation. But if I subtract one, if I go lower and I have 1999, the number before it, how long is that representation? Well, 1999. Whoops, sorry, that was supposed to be an X. 9. Suddenly, it's a smaller number, it's a smaller quantity, yet it has a way longer representation. So for a child learning this, perhaps, you can't just look at those and know which one is bigger than the other one. They're not directly related to the size of the number they're representing or the quantity. And that's very counterintuitive often, whereas decimal numbers aren't like that. If I am writing 2,345 unoriginally versus 57,000, I wouldn't even write the comma, right? That's an extra help. 911, that bigger number is longer in its representation as well. So right away, a kid learning this knows, oh, the right one's bigger. No questions asked. Or if they have the same length, I just need to look at the left digit. So visually and intuitively, the representation makes it easier to compare numbers and quantities, whereas the Roman numbers, they very much lack that. And that's a key feature that you want in your number system. Now, how they came up with that, that's really a cultural question, why the number system was designed like this. It's very interesting how different cultures came up with completely different sort of philosophies for how to represent quantities. But I don't know enough about that side of things. Very interesting, though. Yeah. All right. I don't have anything else. If you have anything else, feel free. But that's chapter 5. Go into chapter 6, I would say. Go in with the same way of thinking, that things are superficially going to look scary, But under the surface, look for similarities. We're going to discuss what is similar to our decimal system, what's different. The differences are going to be obvious. But there's a lot more similarities once we scratch the surface, and that makes things easier to see that, oh, this isn't as strange, as alien as we might have thought initially. It's actually interesting, similar. And maybe some learning happens. Who knows? Who knows?
All right, back to the quiz.
Yeah.
Is there going to be, like you keep mentioning, like page 1, page 2, page 3, page 4, page 5?
Yes.
Is there going to be one question on each page or more than one?
No, it depends on the like for example, if I look at quiz 1, for the Lady and the Tiger questions, they can be a little bit bigger. So there's just one of them on
Okay.
page, what was it, 3? Yeah,
Hmm.
there's just one. But for page 1, for example, there will be an A and a B because those questions are short. State the negation. That's pretty short. That's not worth the same weight as a Lady and the Tiger question. So that
Okay.
would be an A and a B. Yeah, things like that. So most of them, I would say, have an A and a B, like
Okay.
converting one way, converting another way, so that the amount of work on a page is roughly the same.
Okay.
It's not
So we
perfect,
could
but
suspect 2 problem solving.
yeah, go in expecting two little sub questions per page that are they're independent from each other. So I guess 2 questions per page, yeah. But the amount of work per page should be sort of comparable. I think the arithmetic one might be a little longer than others for obvious reasons. But yeah, I think A and a B per for each page. Yeah. But still, if you think about the hour that you have, usually it's a 50-minute class for 5 pages. That gives you 10 minutes a page. So can you convert? Can you do problem 5.4 number 1 and 5.5 number 1 in 10 minutes? Because that would be page 1. So you can sort of gauge how long does this arithmetic take me? It should take me 5 minutes. Or I need to save time from another question, which often happens, to be fair. The negation question, for example, it might not take you 5 minutes. So on average, you're looking at 10 minutes a page, 5 minutes for half a page, which is much longer than you think for these questions because they're going to be so straightforward. I'm not going to suddenly ask you something you've never seen before. It's just what exactly am I going to do? Plus, minus, times? Which one is it going to be? And exactly what is that number looking like? I know exactly which questions are coming my way. Now, in quiz 1, there's a little more variety in some of them. Like the page 4, the other puzzles, there's definitely some variety. Is it a knights and knaves? Is it a house, nationality, color kind of question? Is it something I've never seen exactly like that? And I have to somehow think of strategies that I could sort of transfer to this question. Those are a little bit more involved because they're less predictable. But for the most part, most pages are pretty predictable, uh, cutting down the time that they take. Yeah. It's deceptive. Sometimes an open book test can end up taking longer because you use the book, you have to page around, you have to look for things. It's almost better to pretend there is no book and just use it as a way to check if you happen to have time. That would be my suggestion for sure. But it can sometimes be, oh, I have a book, I'll be fine, I don't have to study as much. The time is going to catch you if you take that approach. But it's up to you. It's up to you. It could be a blessing and a curse. We have 11 minutes. We have time to go over problem 1.4. I'm definitely not doing that. What is 1.4? There's no question coming out of problem of chapter 1. Those problems are just for you to challenge yourself, and if it's too challenging, that will not happen in a quiz. Chapter 1 is very much our introduction chapter. Where is problem 1.3? That you can use the same idea as the basic deductive reasoning template: premise, conclusion, sorry, premise, observation, conclusion. Uh, if you want a clue for how to do it, I can give you a clue for sure. Let's do it. But it's not going to be a test question in any way. We have our basic premise, which is, for example, if it rains, then the grass is wet. We observe something. Now, this is not abductive reasoning. This is correct deductive reasoning. Let's just say today it rains. So then my conclusion is therefore the grass is wet. But the alternative, the premise is the same. The alternative observation could be the grass is not wet. The negation of the second part of the premise. The grass is not wet. And my conclusion then is it did not rain, or it's not raining. Forget the tenses here. So there are two versions to deductive reasoning. Now for problem 1.4, we're looking at that second version perhaps. We're given a chessboard, 2 red squares at opposite corners are removed. Can I fill the board completely with dominoes? Now dominoes following the same argument or the same structure as these paper clips do. That with a domino I cover 2 squares. Can I cover the whole chessboard, standard chessboard, with the corners removed with dominoes? So you want to say something like, if I'm able to do that, my premise, if I'm able to cover the chessboard with dominoes, then what do I know about the board? Let me just rethink how I want to do that. No, scratch that. What do I know about the board? Premise has to be a fact. If I'm able to do it, then certain things there's certain properties once I remove these 2 corners. And then when I think about the dominoes, perhaps the second part of my premise fails, which I can then use to conclude the opposite of the first part. So I want my premise to be, if it is possible to cover the board, then I can say certain things about the board and the dominoes and everything that is 100% true. No one's going to question that. Then I want to observe the opposite of this, and I can conclude that it's not possible. But it's a little advanced, so I'm not going to worry about that and potentially confuse people. If you get it, you get it. If you don't, then we could do it in an email maybe. I don't want to do it here, since the only things coming from chapter 1 are, what do you know examples of the 3 different kinds of reasoning and pros and cons for both. So my apologies if I don't want to show you the answer. And some questions of 2.3. What is problem 2.3? 2.3 is a very important one. Absolutely. I can almost guarantee that's in the quiz. But that wasn't really a big reveal. Am I on page 25? I don't really know page numbers. Yes, I am. Okay. So we could certainly do a problem 2.3. I'm going to do the bottom one. There's one of them that's not in the answer key. It's 4 or 5. I'm not sure. I'm going to go with 5, but it could be 4. Just going to go with my gut, say it's 5. So let's do 5 since it's not in the answer key, I think. So we're doing problem 2.3, number 5. Okay, so we're gonna have a lot of structure here. We're always gonna have 3 sentences. We're always gonna have 3 groups, 3 circles, making it easier. In general, it could be, this is a hard question in general. But for our purposes, we keep it nice and contained. Some doctors are intelligent. So I have doctors, and I have intelligent people, and a sum statement is an overlap. So that will be intelligent people. Then I'm also bound by the second statement. All intelligent people are poets. So my third group is the poet group. All intelligent people are poets. That's an all statement. That means one circle inside the other one, intelligent inside poets. Now, I do have some choice here because I can make the poet circle like this, or I can make the poet circle like this. I don't really know. So I do have some flexibility while still making the first 2 statements true. My aim is to do it in such a way, if possible, that I contradict that last third statement, if at all possible, because then I would be able to conclude this is not a logically sound argument. So the third statement is, therefore, some doctors are poets. Now, regardless of my choices in this case, regardless of my choices of where to put the poet circle, I have to put it around the intelligent people. So regardless of where I put it, it's going to overlap with the doctors. I cannot get around that because the doctors and the intelligent people circle are attached to each other. So I unfortunately cannot get a layout that makes this third statement not true. Some doctors are always going to be poets, unfortunately. So I have to conclude it is logically sound. I'm a little bummed because I was hoping, I'm always aiming to contradict that third one. I see that as a win, but if I can't, at least I know. Yes, fine, I'll give you the logically sound argument.
So whether you did it like that or you circled it all the way around, they're exactly the same.
Yeah, either way, there's a doctor that's a poet. Cannot get away from it. Yeah.
Okay.
Yeah, but if there was a way to do it, then I can conclude it's not logically sound. I just need an example layout. Agreeing with the first 2, but not agreeing with the third one, if possible. And sometimes it's not possible. Yes. So some things to do over the weekend. There's not nothing to do, but I will definitely say a fact that with each week, the workload is going to become easier. Everything is just going to become easier. Just for nothing else, you're getting into the swing of things, so to speak. But because we have our test next Friday, that means we are automatically doing less content next week. So the first week is the one that is fuller than the other ones. So if you feel a little discouraged, things will get better if you just stick with it. If you're feeling good, then more good news. It's just going to get potentially easier in terms of workload and complexity. We have to talk about So part one is very much perhaps a little abstract, a little let's better ourselves first and get some logical thinking skills and critical thinking down. Less specifically focused on elementary school, but with the parts coming up, it's very much more and more. Yeah, I'm gonna do this in elementary school at some point. I'm gonna do fractions. Let's talk about fractions. And it becomes more and more, uh, I guess, teaching focused rather than knowledge focused for myself. So in that sense, it becomes more relatable and easier. Yeah. So keep up with it. I'll still check my email. I'll still keep an eye on Discord if you have anything. But connect with each other. Use the Discord Math 190 SU channel. It's there for you, so you don't feel isolated. Isolation is the worst thing. Worst thing. All right. Any last words from anyone
Hi,
before
can you
we?
hear me?
Yes, I can.
Could you possibly go back to the table of contents where you showed what would be in the test one? I didn't grab everything.
Sure. I think it was this one. I need to go to page 3, I think. Let me zoom out. Something like that, or is that too
Yes,
small?
that's perfect. That's exactly it.
And I mean, I'm as we approach the test next week, I'm happy to repeat these as well. Actually, I should take a screenshot of this. Nah, it's fine. It's all good. Uh, so I'll leave this open a little bit if you want to take notes. Other than that, I will say until Monday and enjoy the weekend.